Hello everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today I've got Santiago who has just completed the course Linux Basics. So you'll be giving us a presentation on that. So first of all, we're going to begin by seeing a demonstration on the real robot where he runs his code base on the actual robot and we see how it works there, and then we'll get into the details about what he did and the logic behind that. Alright, so without further ado, let me now hand over the platform to him so he can begin his presentation. Alright, whenever you're ready, Santiago.
Okay. I have the robots. 1 minute left for I made a presentation, but for troubles and change in the code, but that's for after that.
Yes. I think as we wait for the robot, you can just go through your presentation slides and you give us some details about that, and then once your waiting time is left, yeah.
First going to this?
Yes, I think it's fine for now as we wait.
Okay. I will also open the code. Here I made two different sections. The first are some troubles I have during the coding. It was mainly one here in the function of moving forward for the robot. When was between 0.3 and 0.4. After subtracting the avoiding distance, in my case it was 0.3, and then divided by the speed, which was 0.1. Then I subtract the delay of 1 second, and it has negative values. So at the beginning, I didn't make an else, it only was an if, and it gets stuck in this function every time. So then I made an else in which I do a small forward approach. During here it says 0.1, but I changed recently to 0.07. Okay, here we can see. Here my move forward function. Here I put 0.07. So when the value is between 0.3 and 0.4, it moves slightly forward, and then the front sensor value is smaller than 0.3. So it goes to another function. Okay. Here I explain what I have just did, and another change I did is that at the end of the loop I put this. If during the loop the robot haven't moved, but all the sensors are the same values. If it happens 5 times, I put counter. I showed through the screen that is stuck, and I turn left 4 times, so it changed the direction, right? 180 degrees.
Okay.
I did this before the solution of the problem, but then I realized it was the negative values.
Okay. Alright, so when you did that, did it work before you realized that it was the negative values?
It worked because it don't move, then it rotates 180 degrees, and it goes forward again.
Okay,
but
and then you didn't have negative values. Is that what you say?
What? If I had negative values?
Yeah, I'm asking. So when it rotated 180 degrees out, would you still be getting negative values on your laser scan data, or so?
No. When it turns, it go again to move forward function,
Oh,
and
okay.
it now has positive values because the obstacles weren't there.
Oh, okay. All
No.
right. So you basically avoided the obstacle completely. Okay,
Then
interesting.
but then I realized it was that, and I changed it.
Okay,
But I keep the other
you kept
function.
you kept the other solution in there. So how did you realize that it was the negative values? Did you do any tests?
Uh, by looking to the front right, and front left values,
Mm.
uh, I realized that when it was 0.31 or 32,
Mm-hmm.
between 0.3 and 0.4,
Yes.
it always failed.
All right.
It's
All
an
right.
issue. And then I do the calculations of this program in a paper, and I realized it clearly was the negative value.
Okay. All right. So let's connect to the real robot now, and let's see it running
Yes.
on the robot. Yeah.
Okay. Mm-mm. Here. Okay. I like to put it. Mhm. What's that? Can do it. Mm-mm-mm. No, this is a simulation, right? Sorry. For the real robot. And then. Mm-mm-mm. Put it here. Here are the statistics.
Mm-hmm.
The obstacle avoided. Then, okay. Here front is less than 0.3, so we turn left.
Mm-hmm. Well, why did it turn left there? Is that the first direction that it considers? So does it only turn
Uh,
counterclockwise?
I don't remember here it was. I did it like the example they gave me.
Uh-huh. Okay.
If front left is
Okay. All right. So it first considers the um,
yes,
left index, right?
like mm, here it made a small forward approach because front was between 0.3 and 0.4.
Mm-hmm.
It goes a little bit forward, and then it, here you can see
Mm-hmm.
now it's turning left.
All right. All right.
Yes. Yes, in this case, the front is minus 0.3, my avoiding distance, and left is, I don't remember here, they are both true, the only one false. Well, then I will explain all the code. Okay. Okay, but here in this one, front is 0.2, less than 0.3, front left is 0.27, front right 0.36. So here it chooses the one who has the most distance, which is front right, so it turns right. Then here front is more than 0.3, and the other ones are free too, so it goes forward. Here the same, front is less than 0.3, front left is higher than right, so it goes left, and it's all the same. Now it don't get stuck, so I haven't seen since the function I did from if don't move for 5 loops, it makes a 180 degrees hero. This return don't usually do it because what I did before, what I said before, it only happened since I realized it was negative values. It doesn't happen directly.
All right. So the getting stuck scenario, you're saying it doesn't happen as often, but when you encountered that situation, under what conditions did it happen, right?
What could you repeat? I don't understand.
Did you encounter the situation where it got stuck and your counter increased up to 5, right?
Yes.
5
times.
When did that happen, and how did that happen?
Here, it happened. This only happened when I didn't solve this. It was my first solution, but it wasn't good. However, I keep it to show it.
Oh, okay.
But
all right. So it okay.
Now it don't happen. It never happened.
All right. So
it's like something interesting.
All right. So it didn't happen when it happened when you did not have a way to handle negative values.
The beginnings. Yeah.
Okay. All right.
Now it never happened.
Okay. All right.
For curiosity.
Yeah. Well, it's a good way to document what you did. So yeah.
Okay. Should I explain the code or simulation?
Yeah, I think let's get into the code now. Then we now have a lot more time. We've seen how it works. So yes, let's get into the details of the code.
Okay. Here I think we have the code.
Yeah, maximize that. Yeah. Okay.
First, the setters, linear velocity, angular velocity. I choose the avoidance distance of 0.3. Now all the getters, and I define my functions: turn left and right, and move forward. Here, these values, I choose that by trying. Like at first, I put here 1 second, and it makes tiny movement. So I put more time.
Okay.
And now it makes like nearly 45 degrees.
Okay.
So I need 2 of them to make a turn.
Okay.
And this is the same in negative, so to the right.
All right.
Then move forward. It's here I made calculations to obtain the time, which is the distance.
Mm-hmm.
Distance is my front sensor value.
Yes.
Then I subtract the avoidance distance and divide by the speed. So I have the time the robot should be working,
Mm-hmm.
should be running
Yes.
to reach this distance.
All right.
And I also have to subtract the delay, 1 second. And then I go to the if. If this move time is positive, where I set the speed during this time and it moves that distance.
Mm-hmm.
And if it was negative, I do the small forward approach until the front value is less than 0.3.
Mm-hmm. Mm-hmm.
These are a counter for the what I did in the function of it if it gets stuck, if it during 5 loops have the same values. What I said before, it never happens, but I did it like that. Put it on 0, and then I keep adding 1 in these cases, and when it's 5, I return them to 0. Okay, now here in the while, I call all the getters. Yes, left, front. Okay, I show in the screen front, left, and front, right, which are the more important to do all the functions.
All right.
And I define when they are free. It's when they are free when the value is higher than 0.3, my hypotenuse distance.
Mm-hmm. So
Here, 1 for each.
All right. So your robot will move on the first value that encounters to be greater than 0.3, right?
Yes.
All right. So let's say scroll up a little bit. What would be the effect of changing the order? Right, so I see that you're taking into consideration front left, and front right. What if you change the order? What would happen? For example, in the corner that we it first encountered.
Where if I change the order, when?
Yes,
Here?
yes, the order of which laser scan data is being checked first. So let's say you had changed and you started considering front right instead. What would happen in the first case where it was facing the corner? That we started with earlier, and it rotated counterclockwise.
Well, if I change, you mean if I call here, for example, front right?
No. If you change the order of processing your scan data, so
the order.
Yes, so you've got front left being processed first, right? So if then front left is greater than obstacle avoidance distance, right? Right. If you had front right there, what would have happened in the previous case that I explained now?
The order of these ifs doesn't matter.
It doesn't matter.
You put this, it doesn't matter. There are all the 3 ifs happen before this.
Or before execution.
All the other ifs which have all the possibilities, so it doesn't matter. If I put this if, for example, after one of these functions, it won't work because I set the value here, and it won't. The front free won't be true or false. It won't have a value.
Okay, it won't have. All right.
If I put it after. So here are the 3, and then I define all the possibilities.
Mm-hmm. Okay.
Like the front left, front free, front right.
All right.
Okay.
So you do reset. You do reset with the either left force or left right. Okay, I see.
Each time the if begins, it's assigned. it sets new values.
Okay, it does get new Boolean values. Okay, that's good. That's good. Makes sense now.
Okay, now I define all the possibilities, like false, false, false. I follow the guy. I follow the guy. If there are all three false, if left is bigger than right, it will turn left. Else, it will turn right.
Okay. All right. All right.
Here, if only it's true, the right, it will go right. If only front, it will go front. If front and right are free, it will turn right. Here, the other case, no. Front left and front right, no. Only front left, it will go left. If front left and front right depends on the value, which is bigger, it will go to that way.
All right. All right.
Front and left, it will go left.
All right.
If they are all true, it will go forward.
All right. Let's speak. Let's see your statistics script now. So, can you give some detail to that? Yes, the robot statistics.
Here.
Yes. So let's see the code. That's the one we want to see. You can stop the execution of the obstacle avoidance script now.
Stop it?
Yes.
Here it made I'm stuck. It have never happened to me.
Because of the proximity of the obstacles. Oh, it's fine. I want to see the. So, can you give some detail?
Statistics?
Yes, the robot statistics script in the IDE.
Okay. This is, for example, the top distance. All the distance it have done. See, the robot have moved a total of 4.5 meters here.
Right.
Each time it reload. Okay.
Okay.
The direction.
Can you see the implementation though? I want to see the implementation. Yes.
This, no? Okay. Here I define all the getters. There's a lot. Oh, sorry. Here. But okay. Here, a loop in which I show through the screen the out of this, see all the different variables, which I get from the robot function, all the getters and all the setters.
Okay.
I put it like that. And sleep of 1.5 seconds, so it don't show all the time so fast, and it goes like the obstacle avoider.
All right. Thank you very much, Santiago. Thank you so much for a wonderful presentation and for letting us know the details of what you did exactly. All right. So just turn around and we'll be right back. Alright everyone, this was Santiago's presentation, and we would like to thank him for having the courage to come and showcase his work, and we'd like to encourage all those of you who would want to try out this course to do so, and then it will definitely teach you the important fundamentals about Linux for robotics. And until next time, keep pushing your ROS learning.